Hello dear students, in this video we'll see some example questions where we have to find the value of student's t-statistic. So here is a question: a machine which produces mica insulating washers are used in electric devices is said to turn out washers having a thickness of 10 mils. A sample of 10 washers has an average thickness of 9.52 mils with a standard deviation of 0.6 mil. Find out T. So here we can see that machine which is producing mica insulating washers, it produces washers having average thickness of 10 mils. A sample of 10 washers had an average thickness of 9.52 mils and a standard deviation of 0.6 mils. We need to find T. So here X bar is 9.52 and the sample standard deviation S is 0.6 and mu is average thickness is given as 10 mils and N is a sample of 10 washers had this average thickness. So the sample size is 10. So we can find T as X bar minus mu upon S by root of N minus 1, or it is X bar minus mu upon S into root of N minus 1. When we substitute all these values, we will get the answer. So it is 9.52 minus mu is, it is 10 upon S is 0.6 into root of 10 minus 1. So this is equal to minus 0.48 upon 0.6 into root of 10 minus 1 is root 9, which is 3. So this, when we simplify, we get it as 0.6 or it is minus 2.4. So this is the value of T. So here the sample standard deviation is given. So we have taken small s and we have used this formula, X bar minus mu upon S by root of N minus 1, or it is X bar minus mu into root of N minus 1 upon S. Now let us see another question. Here the sample observations are given. 10 individuals are chosen at random from population and their heights are found to be in inches. These values. If mean height of the universe is 65 inches, find T. So here mu is given and the sample size is 10. Here we have 10 individuals who are chosen and their heights are given here. So here mu is 65 and N is 10. So let us draw a table like this to find the unbiased estimator of population variance S square, and then let us find S. So here I will explain both the formula. T is X bar minus mu upon S by root 10, and here we will see T is equal to X bar minus mu upon small s, sample standard deviation upon root of N minus 1. So here the various heights I have taken here. So summation xi, if we add all these, we get it as 670. So X bar is 670 upon 10. So it is 67. So here let us find xi minus x bar. X bar is 67 and then xi minus x bar the whole square. So this is xi minus x bar or xi minus 67. So 63 minus 67, here minus 4, minus 4, minus 3, minus 2, minus 1, then 2, 2, 3, 3, 4. Now let us find the square of each of these. So it is minus 4 the whole square, 16, 16, 9, 4, 1, 4, 4, 9, 9 and 16. So that we get this summation xi minus x bar the whole square. When we add all these, we get it as equal to 88. This is 88. Now let us find capital S. It is root of summation xi minus x bar the whole square upon n minus 1. So it is root of 88 upon, here n is 10 minus 1, or it is root 88 upon root 9, which is 3. Square root of 88, the value is 9.38 divided by 3. It is equal to 3.13. So yes is 3.13. Now let us use the formula with capital S. So T is x bar is 67 minus mu is 65 upon 3.13 into root of n is 10. So this is 2 by 3.13 into root 10, we know it is 3.16. So this, when we simplify, we get it as 2.02. So this is one method of finding T, where when the sample observations are given, we can use capital S and use this formula. The same question, we can also find the sample standard deviation, and we can use the formula with small s and find the value of T. So small s, it is nothing but it is root of summation xi minus x bar the whole square upon n. So it is root of 88 upon n is 10. N is 10. So root 88 upon 10. It is root 8.8. Here root 8.8, it is 2.97. So T is, when we are using this small s, so T will be x bar minus mu. 67 minus 65 upon small s, it is 2.97 into root of n minus 1. That is into root of 10 minus 1. So it is 2 by 2.97 into root of 10 minus 1 is root 9, which is 3. So again this, when we simplify, we will get 2.02. So again we will get 2.02, the same value only. So if you are getting confused with this capital S and this n minus 1, always remember this formula. T is equal to x bar minus mu upon s by root of n minus 1, or T is equal to x bar minus mu upon small s, sample standard deviation, upon root of n minus 1, or x bar minus mu upon s into root of n minus 1. So this formula alone can be remembered, and we can find the value of T for one sample t-test. Now let us see one more question. A random sample of size 16 has 53 as mean. The sum of squares of deviation from mean is 150. Find T if the population mean is 56. So here the sample size is 16 and the sample mean is 53. Here the sum of squares of deviations from the mean is given. That is 150. So here sample size is 16, sample mean x bar is 53, and population mean mu is 56. Then the sum of squares of deviations from the mean, summation xi minus x bar the whole square. This is given as 150. So here let us find T using capital S, and here let us find T using small s. Either way we will get the value of T same. Whichever is comfortable and whichever formula that can be remembered easily by you, that formula can be followed. So if we take capital S, it is root of summation xi minus x bar the whole square upon n minus 1. So it is root of 150 upon 16 minus 1. So it is root of 150 upon 15. It is root 10. Root 10 is nothing but 3.16. So now let us find T using capital S. So T is x bar minus mu upon capital S into root n. So x bar is 53, mu is 56, and capital S we found it as 3.16 into root of n is 16. So it is minus 3 into 4 upon 3.16. So this when we simplify, we get minus 3.79. And now let us find the sample standard deviation and let us find t. So this is method 1. This is method 2. It is alternate method. So small s, it is root of summation xi minus x bar the whole square upon n. This is sample standard deviation. So it is root of summation xi minus x bar the whole square is 150 upon n is 16. So it is root 150 by 4. Now root 150 is 12.25 upon 4. So the sample standard deviation is 3.06. Now using sample standard deviation, the formula for t is x bar minus mu upon s into root of n minus 1. X bar is 53, mu is 56 upon sample standard deviation. This is sample standard deviation. Into root of n is 16 minus 1. So this is minus 3 by 3.06 into root 15. So root 15 is 3.873 upon 3.06. Again this when we simplify, we get it as minus 3.79. So the value of that same, the value of t will remain the same. When we use small s and use this formula, or when we use capital S and use this formula. So whichever method is comfortable and whichever method can be remembered easily, that method can be followed. So if there is confusion with this capital S, don't use this method at all. Remember this method alone. So that for all questions, whether the sample observations are given or the sample standard deviation is given, we can use this formula itself. If sample observations are given, find the sample standard deviation using this formula and again find the value of t using x bar minus mu upon s into root of n minus 1. I hope this video was useful for you. I wish all the best for your exams. Thank you for watching.